Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's easy level puzzle. And take that easiness with a grain of salt because it's considered easy by the people on the Logic Masters Germany forum, and there's a lot of really smart people there. Today's puzzle is called Purple Lines by Wiggle, and here are the rules. We have normal Sudoku rules apply, which means place the digits 1 to 9 once each in every row, column, and box. The grid is covered in fog. Placing correct digit clears the fog somewhere in the grid. No guessing is required, of course. So this is dynamic fog of war. It's not standard fog of war. So placing the correct digit clears the fog somewhere in the puzzle. We don't know where. It could be in the cell itself. Hopefully it is, but it might not be. Anyways, let's continue. Blue lines are modular lines, where every connected run of 3 cells along them must contain a 1 digit each from each modular set. And the sets are 147, which are 1 modulo 3, 258, which is 2 modulo 3, and 369, which is 0 modulo 3. So, for example, these 3 digits could be something like, I don't know, 9 and 8. And this would work because these 3 digits must have 1 digit from 1 modulo 3, which is 1 digit from 2 modulo 3, which is 8, and then 1 digit from 0 modulo 3, which would be 9. So this would be an example of a valid, potentially a valid set of 3 digits along this modular line. And that must be for every set of 3 digits on the modular lines. The red lines are parity lines. When going along them, digits alternate between odd and even. So since this is an even digit here, these 2 digits must be odd digits. And then finally, we have purple lines. What? The title mentions purple lines. What were they again? Maybe they were Renban. The digits on a Renban line form a set of consecutive non-repeating digits in any order. So, say we had a purple line here, and it was a Renban. We do not know if it actually is. Then this would have to form a set of consecutive digits. And you could have non-repeating digits. So you could have something like, I don't know, 9, 7, 6, and 8. And this would be a valid Renban line if it were a Renban line. We don't know if purple lines are Renban lines or if they're a different type of line. No, that was wrong. No purple line could ever be a valid Renban. Ah, now I remember. They just combined the rules of the other 2 lines. Okay, so it's not a Renban. Okay, never mind. Never mind. I just completely explained a Renban line even though it's not a Renban line. So a purple line is always a valid blue line and a valid red line at the same time. Good thing I remembered that. Now that I'm done explaining the rules, I have to get going. I really hope the rules will help you with solving the puzzle. So, okay, so purple line combines the rules of the blue line and the red line, which is the modular lines and the parity lines. So that means you have to have every 3 digits along the purple line must contain a 1 digit each from the modular sets 147, 258, and 369, which are 1 modulo 3, 2 modulo 3, and 0 modulo 3. And they have to alternate between odd and even digits. And those are all the rules. If you like to play along, there's going to be a link in the description. And now I'm going to get started. Let's go. Okay. So these 2 digits are the same set of modular line because these 3 must be different sets and these 3 must be different sets. Well, these 2 digits are going to stay the same, so therefore these 2 must be the same set. 1 is 1 modulo 3, so there cannot be another 1 modulo 3 on this line. And the only 2 modulo 3 is an 8. So this cannot be 2 modulo 3 here. So this must be 0 modulo 3. So this has to be 3, 6, or 9. And this must be an 8. 2 is next to odd digits, so these cannot be odd digits. They therefore are 3, 7, or 9. Sorry, they have to be odd digits because 2 is an even digit. Well, where is the 4 in this box? It must be here. So this is 4. 6 is guaranteed to be one of these 2 digits. 7 has to be one of these. This is a modular line. It does not have 4 or 7 on it, so the modular part that's 1 mod 3 is a 1. So 1 has to be one of these digits here. 2 modulo 3 can be 2, 5, or 8. We don't know which, and we could have 3, 6, or 9 along it. Okay. So this could be 2, 5, 8, or 3, 6, 9. So this cannot be 5 or 8 here. So this is 2, 3, 6, or 9. 2 can't be here, and we have to have 1 here, right? Oh, 7 eliminates 7 from being here. We have a 3, 6, 9 triplet in row 8, which eliminates 3, 6, 9 in the rest of the row and the rest of this box. So this must be 7 here. So no 3, 6, or 9 there. So this is 1 or it's 2, 5, 8. This alternates parity here. We have a 5 here, so this cannot be 5 here. The 5 in row 8 then cannot be here because the 5's in the boxes. Can't be, this is a 7, so 5 has to be one of these 2. The odd digit here cannot be 3 or 9 because of the 3, 6, 9 triplet. Can't be 7. Can't be 5 because of the 5 in the box, so that the odd digit in one of these 2 digits must be 1, which eliminates 1 in the rest of the row. So this is 2, 5, or 8, which means these cannot be 2 modulo 3. So this can't be 2. This is 3, 6, 9. This then must be a 1. So that's a 1. We have a 9 here. That's 0 modulo 3. This can't be 4 or 7. So that this in or 1 because of 1, 4, 7 in the box. So this cannot be 1 modulo 3. Can't be 0 modulo 3. It must be 2 modulo 3, but can't be 5 or 8. So this is 2, which eliminates 2 in the rest of the box. This must be 1 modulo 3. Cannot be 7 or 1. So this is 4. Okay, so this is 3, 6, 9. This is 1 modulo 3. So this has to be 2 modulo 3 or 0 modulo 3. So it's 2, 5, 8 or 3, 6, 9. And this can't be 2 or 9. This must have an even digit with it. Cannot be 6, but it could be 2, 4, or 8. So we have 1 with 2, 4, or 8 here. Remaining digits in row 7. We have 3, 6, 7, or 9. This is 7, so this must be even. So this is 2, 4, 6, 8. Cannot be 2 because of 2 in the column. 4, 6, 8. This is odd. 1, 3, 5, or 9. This is even. 2, 4, 6, 8. This is odd. Cannot be 6. That's 3, 7, 9. Which makes this even. 2, 4, 6, 8. Okay. Remaining digits in row 9. Actually, let's do remaining digits in column 1. 3, 5, 6, 8. 3, 5, 6, 8. No 3 or 6 here because of a 3, 6 pair in the row. 3, 6, 9 triplet in the row. So this is a 5, 8 pair in row 8, which eliminates 5 and 8 in the rest of the row. So this can't be 8. This is 1, 2, 4 as a triplet then. This must be 3, 6, and 9. Remaining in box 7. This is 2 or 4 and is even. This is 8 and 1 out of 3, 6, or 9. We're not sure which. This we don't have anything else in. 7. Where is 7 in row 6? Can't be here because of 7's in the boxes. Can't be here because of these must be even. So this has to be 7 here. So that's 7, which eliminates 7 here, which means one of these two is 7. We don't know which. So this is even. Let's start marking even and odds because we seem to be using that a lot. Even, even, all the 7's are odd. All the 9's, there's only one 9, is odd. All the 2's are even. All the 1's are odd. All the 5's are odd. 4's are even. 8 is even. These are odd. This is 3, 6, or 9. We don't know if that's odd. This cannot be 1 because of 1 in the box. So this has to have 2 odds and 2 evens on this parity line, which means we have 4 evens in column 9, so the rest of the digits must be odd. So this is odd and this is odd. Therefore, this can't be even. It's not 6. This is 3, 7, 9 here. One of these is even, one of these is odd. We're not sure which is which. Same with this. This is odd. So we have one even and one odd here. We're not sure which is which. This can't be 1 because of 1 in the column. So this must be an even, which makes this odd, which makes this even. So this must be 1 here. Therefore, this is 6 here, which eliminates 6 in the rest of the row. This is a modular line. This is a parity line. So that can't be 6 here. This is odd then, because it's 3 or 9. This can't be 9 because of 9 in the box. This has 1 of each modular. And so 4 has to be one of these two. 3, because it can't be 1 or 7. So 4 cannot be here because of 4 in the box, so 4 has to be one of these two. This can't be 4 because of 4 in the column, so this must be 4 here, which means this... Where are the purple lines? Are these purple? These are blue, right? Are they blue or are they purple? I think these are blue, right? I don't know. Everything's starting to look a little hazy for me. Anyways, it has to follow the modular things. So this must be 1 modulo 3 because that's 3 away. It cannot be 7, but it could be 1 or 4. These have to be 0 or 2 modulo 3. So it's 2, 5, 8 or 3, 6, 9. This can't be 9. This can't be 8. No 5 here or 2. This has modulo 3 also. So this is a pair of odd and even, odd and even, and odd and even, guaranteed. So that means this must be a pair of odd and even. We're not sure which. So 4, where's 4 in column 6? It must be one of those two. I don't know. With the coloring, everything seems like it's all sort of purplish. Let's see. Do we have anything else? This has 3 from the same modularity. Or sorry, 3 different ones from different modularities. Remaining digits of row 4. Let's do 2, 3, 5, 6, 8, 9. Can't be 2 or 5. This can't be 6. This can't be 5. Where's 7 in column 4? It must be one of these 3. Where's 7 in column 2? It must be one of these 3. Hmm. Okay, what else do we have? Hmm. Where's 4? Oh. Where's 4 in column 2? It must be one of these 3. So, one of these is guaranteed to be 1 modulo 3. Because both 4 and 7 can't be here. So one of them has to be here. Which means this cannot be 1 modulo 3. So one of these two is 1 modulo 3. This can't be 1 modulo 3. So we have 2, 5, 8, 3, 6, 9 there. 2, 5, 8, 3, 6, 9 there. One of these is 4, 7. That means this is guaranteed to be 4 or 7 here. The other one is 0 modulo 3 or 2 modulo 3. So if this is the... If this is the 4 or 7, that would mean if this is 1 modulo 3, this has to be 7. If this is 1 modulo 3, that means this must be 1. So either this is 1 or this is 7. We're not sure which. 1, interestingly enough, has to be one of these 3 digits here. Ah, where is 1? 1 cannot be here because where is 1 in column 6 specifically? And this can't be 4 because of 4 in the box. Right, we have a 3, 6, 8, 9 quadruplet, so this must be a 1, 4 pair. There we go. So since this is a 1, 4 pair, this cannot be 1 here. So 7 does have to be here as the set, the 1 modulo 3. So this cannot be 7 here. It can't be 4 here either. So this becomes a 4-7 pair here. So this can't be 7 here. No 7 here. This is a set of 3 unique digits. So it has to have a 1 here somewhere. So this must be 1. And it has to have 1 out of 2, 5, 8, and 1 out of 3, 6 here. But we don't know which. This is 4, that's 1 or 4, 1 or 4. Huh. 2, 3, 5, 6, and 9. No 8 here. Remaining digits of column 7. We have 2, 3, 4, 5, 8, 9. If this were even, this would be 1. So that's fine. Hmm. Hmm. Okay. 7's one of these 4. Huh. I don't see any purple lines. Maybe it's just me. But the thing is, this... Maybe the blue line is a purple line. Everything's starting to blend now with the coloring. Maybe I should just remove the coloring. Um... Hmm. Yeah, let's remove the coloring. Let's make sure that we have this as 1, 3, 7, or 9. We do know 1 has to be one of these 3 digits, though. Let's remove the coloring. It's starting to make me feel a little color blind. Wait, is this red now? They all look purple to me. What's going on? Are they all purple now? I'm just now confused. I thought I saw this as red. Maybe it is changing them to purple. And maybe that's the case then. So then that would have to... They would have to... I swear, is it changing colors? It's changing colors, isn't it? It's changing colors, I swear, right? Now I'm just, like, confused. Because I'm like, I feel like it's changing colors. But I can't tell. Okay, this is blue and red. Yeah, these are distinctly blue and red. But I feel like they're changing colors. Still blue and red. I feel like it's changed colors now. Yeah, they all kind of look purple now. Yeah, I think they're all purple. So... Huh. Okay. Is that the case? I think that is the case. They all have changed to purple. Interesting. Okay, so then this has to be... So this was... Right, they're all purple. So this is 0 modulo 3. 1 modulo 3. This must be 2 modulo 3. So that's 2. This is 4. This was kind of cool. Kind of mind blown by now. I'm just kind of like, whoa, what the heck happened? So this cannot be 6. So this must be 6 here. We have... Okay, this is 0 modulo 3 no matter what. This must alternate between odd and even, so this is 8. That's 3 and 9. This is 5. So this cannot be 5 here. This must be even, so it's not 3, it's 6 or 8. This must be even, so no 3 or 5. Cannot be 8 here because of 8 in the column. This is even. Sorry, this is odd, so this is even. Okay, yeah, so then... Maybe I need to go back to coloring. My mind was getting like kind of blown. I'm like, what's going on? And then everything's becoming okay. So everything is a purple line then. So these are odd. 2s are even. Do we have 3s? No. 4s are even. 5s are odd. 6s are even. 7s are odd. 8s are even, and then 9s are odd. So this can't be 6. This must be odd and odd. These are odd. We have odd here. This is even, odd, even, even. So this is even, which forces both of these to be odd, which forces both of these to be even. These are both even. This is odd, which forces both of these to be even. Then forces both of these to be odd. Forces this to be even. So since this is even, this must be odd. So this must be 1. This is 4. 4 is even, so that means it must be next to an odd digit, which must be next to even. So this is 4 here. That's 7. Unless I'm reading too much into this being turning into purple. I feel like these are purple now. I don't know. Maybe I'm wrong there. 359. We have 3 odd digits here. One of these is we have 4 odd digits here. One of these is odd. That means the rest must be even. So this must be even and this must be even, which means this is 8. This cannot be 8. There's no more 8 here. This can't be 3, 5, or 9. It's 2 or 4. This must be odd. So it's not 2 and not 6. This is even, so no 3, 5, or 9. This is odd. Hmm. 5 eliminates 5 from the rest of the column. So this is 3, 6, 8 as a triplet, which eliminates 3, 6, 8 in the rest of the column, or the rest of the box. So this can't be 3, 6, or 8. It's 2, which eliminates 2 here, so that's 4. This then must be 6 or 8 here. 4 eliminates 4 in the rest of the column, so this has to be 2 as an even digit here. Am I seeing things? I swear they don't look like blue and red anymore. It looks like all the same color. Anyways, this is 2 modulo 3, which makes that a 5. This is 0 modulo 3, which makes that a 6. This can't be 2 or 6. It can't be 5. It's 3 or 9, which makes that 0 modulo 3. That makes this 0 modulo 3, so that's 6. This is then 2, which makes that a 6. So no more 6 here. That's 3, 8 as a pair. This is odd, so no 2, 6, or 8. This is 0 modulo 3. This must be 2 modulo 3, so that's 5. Which makes that an even 2 modulo 3, so that's 8. That eliminates 8 here, so it's 6. This cannot be even because all the evens are taken, so this is odd. No 6 or 8. This can't be 2, so where's the 2 in column 7? It has to be here, so this is 2 and is even, therefore these are odd. This cannot be 2 modulo 3 because it's a purple line, that's 3 or 9. This is 3 or 9 also, which eliminates 3 and 9 in the rest of the column, so this can't be 3 or 9, it's 6, which means this can't be 6, it's 3 or 9, so that's odd. This is even, which means the remaining digits in column. This can't be 3 because of 3-8 pair in the box, so this is 9, which makes this 3, which makes that 9. I don't know if I'm doing this correctly. Maybe I'm just seeing things. I don't know. I'm starting to question my sanity here. Remaining digits here are 1 and 5, but we need to have a 1 as the 1 modulo 3 on this blue line. It was blue. So this can't be 1. Therefore, this is 5. This can't be 6 here. This can't be 2, 4, or 6. This has to be 8. And is blue, so these are red, which makes this blue. This is red. Cannot be 7 because of 7 in the row. I don't know if I'm doing this correctly. I might not be. Remaining digits in column 5 are 2 and 1. This can't be 1 because of 1 in the row, so this is 2, which makes this 1. I must be doing it right. Blue, red, and this is red. We have 5 reds in box 5, so this can't be red, it's blue. This must be blue, and then this is red. So this is 8, and we have 3 here. This is not 0 modulo 3 because we have 6 here. So this must be 2 modulo 3, it's 5. This then cannot, this has to be 1 modulo 3 here, so that's 4. This is 0 modulo 3, so that's 9, which makes that 7. 9 eliminates 9 here, so that's 3. This is 3 or 9. 3 or 9. 3 or 9 here, so this must be 1 modulo 3, because we have 2 modulo 3 and 0 modulo 3 here. So this is 7. 1 modulo 3. We don't know what this is. This is 1 modulo 3 and is 7. So this must be even, which is an 8, which makes this 3 and is odd. So this is a 6-8 pair, but this 8 eliminates 8 from being there. So that's 6. This is 8. This must be odd because we have 4 evens in that box. This can't be 2. So this must be the odd here. We have two more odds in row 3. That leaves this as odd and this as even, and this is a 2. That leaves this as an 8. So we have 1, 2, and this is 3 or 9. This is 6, so this must be 3 or 9 also, which forces this to be even and is a 6. This is odd. So we have 6 here. This 5 eliminates 5 here, so it's 3, 9 as a pair. This must be 1 modulo 3, because none of these are. So this has to be 1 here, which means this can't be 1. This is 3, 9 as a pair. That leaves this as a 5. That leaves that as a 1. This has to be 5 here. This is 3 and 9. The problem is this could be either 3 or 9 here. Right? How do we disambiguate these? This can't be 4 or 8, it's 2. That's 2 modulo 3, 2 modulo 3, 0 modulo 3. Yeah, how do we disambiguate here? Blah, 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 blah. No thing is required. Blue has every connected run of 3. Let's continue. No purple line could ever be a valid Renban line. So this can never have a valid Renban. So that's how we disambiguate. So this cannot be 1, 2, and 3. This must be 1, 2, and 9, which makes this 3, which makes that 9, which makes that 3, makes that 9, makes that 3, makes that 9, 3, 9, and 3. And that's how you solve it. Okay. Huh. Interesting. Yeah, so because of the disambiguation, I think you have to read carefully about that. Interesting. Not sure if I like that or if I don't like that. I mean, it's clever. And when you basically, anytime you have that sort of confusion where you're basically like, wait, is this actually, how do I get to the actual solution with disambiguation? I think you have to read the rules carefully. No purple line could ever be a valid Renban. Yeah. I don't know. Very cool, actually. The changing colors of the lines was, I don't know. It was sort of mind blowing because I was just like, wait, am I seeing that correctly? Are the kinds changing colors? What's going on? But I think it was, so Well, I mean, obviously it was. So, because there's no other way to disambiguate. But for a little bit, I was like, wait, is my coloring things like changing the way that I'm viewing it? But it was actually changing the colors of the lines. So that's clever. Um, Definitely something different, which is cool. You know, it's always nice to have something a little bit different. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.